Hi everyone, welcome to data visualization with the GGPlot2 in R programming. This is a live lecture for R programming. We are going to see how you can do data visualization with the GGPlot, and we will be learning here all the aspects of GGPlot2 library, or you can say the package in R programming. So before we get started with this lecture series, you need to understand what was the idea behind to design this GGPlot2. The GGPlot, also referred as GG, this stands for the grammar of graphics. And if you are curious about to know more about this GGPlot2, there is research paper. This research paper was published few years ago, and this paper discussed about the layered grammar of graphics. The layered grammar of graphics means there is graphics, and then you are going to apply here the extra graphics layer by layer. So that is why it is referred as layered grammar of graphics. This GGPlot2 are built up using the multiple functions connected with the plus sign. We will discuss it later in these lectures, where I'll be showing you how you can add multiple layers together by using this plus sign. Alright, so these are the some of, you can say the section are the part of this GGPlot2, which you can use to plot your GGPlot, to plot your graphics. There will be the data set, which will be given to your GGPlot. Thereafter, there is aesthetics. So there is a function, its name is AES, which is aesthetic. Alright, so this aesthetic is responsible to design overall, you can say the aesthetics of a graph, like setting the color and setting the font size and overall figure size and all those things you can set by using this aesthetics. Actually, this GGPlot doesn't plot anything. GGPlot just set outer layer of your plot, which is actually axis. So it just create a canvas there, GGPlot. GGPlot itself does not plot anything. It just create a canvas there. By the help of layered graphic, which I just told you earlier, that by the help of this layered graphic, you create there a multiple layer of graphics. Like you create a layer of color, size, that's mean aesthetics and other types of the data plotting, etc. So a general syntax of this GGPlot will be something like this. There you will be having a GGPlot in which you will pass here a data set. Then you will also pass their aesthetic, and thereafter you will add here a geom point. So this geom point will tell you that what type of plot you want to plot there, whether you want to plot here a line plot or you want to plot here a bar plot, or what type of plot you want to plot here. So that can be decided by here this geom point. Alright, perfect. So let me restart this kernel. So here I'm just going to restart and clear all these output. Alright. Let's go ahead and get started with the R package installation and its loading. So whenever you start your R package, then there is a library path and where all the R packages are stored. So you can get the current working library path. Just you need to type there lib path. As soon as you type there lib path and just run it, there you will get these are the two library paths which are being used currently in our GGPlot2 plotting. In this Jupyter notebook, these two library path is being used currently. So the first path is actually this user path, which is placed at user Lakshmi document R and Win library 4.0. Another one is here, this one is native library, which is inside this Anaconda environment R4 base library R library. Alright, so this one is a native library created by environment in Anaconda, and this one is user library for R4.0. And then we are going to just set here a manual library path there this library path is inside this users. There you have this KGP document, rwin, library and 4.0. Alright, just run it. Thereafter I'm just gonna run it. Then this library path is set here. Just go ahead and install these packages here. So I'm installing these packages, GGPlot2, Libridate and GGalley. So why this GGPlot will be used to will be used for here general plotting, like the plot, line plot, bar plot and other type of the plot. Libridate will be used for the parsing of the date in the data set. And then there is another one is the GGalley. So this GGalley will be also used later on for the pair plot there. All right, let's go ahead and just run it. And if you want to use here autocomplete, you just need to press there the tab, because whatever you write here, let's say you want to write here library, you don't need to write everything there. You just write there lib and just hit here tab. You will see there is suggestion. So the suggestion says that, okay, these are the suggestion which you can actually select any of these suggestion. All right, let's go ahead and run it. So with this, these libraries are included in Jupyter Notebook, like GGPlot2, Libridate and GGalley. So these libraries are included in Jupyter Notebook. All right, let's go ahead. First of all, I'm going to show you how you can load COVID-19 dataset. Thereafter, I'll be showing you how you can use GGPlot2 to analyze and plot COVID-19 dataset. So the first of all, we are gonna get here the current working directory. So this one is current working directory currently. All right, and then I'm going to read our dataset, COVID-19 dataset. So this dataset we need to read here. You can just search this. If you search it, you will get it at my repository. So at this repository, you will get here. All right. So you just need to click on here. There you will get, all right, COVID-19 pre-process dataset. So this one is my repository here. Lakshmi made it, COVID-19 pre-process dataset. And thereafter, you need to click on here this pre-process. Just click on this pre-process. And this package is actually updated the 5 days ago. Don't worry about that. So there I'm gonna select, we are going to select COVID-19 data clean. So there we are gonna select this one. All right, just click on this raw. If it is not visible, let me just zoom in so that you can see it clearly. All right, I'm just gonna navigate it one more time so that you can see it here. So there I'm gonna select here COVID-19 data. Then click on this view raw, and thereafter you need to just get this get this URL. And thereafter, I'm just gonna put this URL here. Just run it. Now your CSV file will be automatically read from online URL. So there, this data is stored inside this data variable. If you want to check the structure of the data, so there you will get the structure of data. This data structure says that you have currently the data frame, which have total 97 thousandths of the line, which is actually objects. That means these number of rows are there in the data set. There is the date. So this date column is having the type of the character, which is a string. That is for, we will be using here Libridate. All right, I told you that we will use this Libridate to parse this date. So this date is currently in a string format. Later on, we will convert this date into a date time. There you have province, state, country. In a country, you have all the country, the COVID data record for all the countries. You have the latitude and the longitude for all the country, and respective the province and states there. These confirmed cases and recovered and the death and active cases. So these cases says that how many number of cases, how many in total number of cases has occurred in a particular country. All right, so we need to first convert our this date type into the date type. There we are going to use here month, day and year. All right, so there you have month, day, year. Just run it. All right, so it says that All right, just a second. It's actually different here. If you notice, there is year, there is month and day. So it's actually like this: year, month, day, YMD. Just run it. As soon as we run it, it's going to parse there. All right, so there you get this data. Now if you notice this data, the type of this data of this date column is now currently date, and it says that there is NA, so we need to just read it once again, otherwise yeah, this NA is coming because we had error previously. All right, just run it once again, and there you just run it. All right, so we have got the type of this date as a date. I'm just gonna comment this one. There, if you check the structure, now in the structure we are getting the type of this date as a date. Now it is correct. There you have got this date variable. Now we will be able to use this date variable for a filtering of the data. Thereafter we are going to also install here a plar package. So just install this plar package. Once this plar package is installed, thereafter we need to include it in our Jupyter notebook. So just include this in our Jupyter notebook so that we can use the functions of a plar package. Thereafter you will notice here dplyr, there this dplyr data, date, country and num column wise. So it is actually being used for a group wise. So this one is group by. All right. So we are doing here a group by. So I can simply write here doing group by. So there we are doing a group by the date and the country. Thereafter we are summing all the data. That's when moreover we are just trying to remove this province state data. All right, so we just trying to remove this particular data, and we are going to sum all the corona cases which has occurred in the country and date wise. So let's say if there are 7 states in a particular country, then the data for all the state will be summed together and it will be assigned to that respective country. And if you check here a structure of the data, now you don't have this province and state because we have done here a group by. So all the data now have been processed as a group. Thereafter we also want to remove the latitude and the longitude. These are not required, so we have just removed that. Now we have these number of data, and these data we need now. We have here date, country, confirmed cases, recovered cases, death cases and active cases. So these cases are actually total cases occurred for a particular country on a particular date. You can also select here a subset of the data for a particular country. In this line, a data is selected for a country US. So if you type there a subset is a function of a dplyr package, and by the help of the subset we select here, actually we filter out the data. So there you have a subset data country equal to US. So we are just going to get the data, all the data for country US. And if you type there a date equal to maximum date -3, it's going to give you the latest date -3. That's mean, let's say if the data has data is available for 3rd of December, then if you put there the -3, then you will get the data available for 30th of November because it's a -3. That's mean you need to go 3 days before. So why I'm putting here a -3? Because let's say there are many countries which are actually not updating the data all the day. So it's pretty much possible that you will get wrong data for a particular country. So that's why we are doing this. All right, let's just run it. Thereafter we are just going to run it. So in this we are going to just sort out our data in a descending order. Thereafter we are going to get here the data for top 10 countries, and then you will get here this data for top 10 countries. There you will get. All right, so there we are getting the data for top 10 countries. In the top 10 countries, you will notice that these are the countries which have most number of cases. There you have US, India, Brazil, Russia, France, UK, Turkey, Italy, Spain and the Germany. So these are the only countries which have a most number of cases of the corona cases. Let's go ahead and get started with the bar plot. So there we are going to discuss a top 10 worst hit countries. In the top 10 worst hit countries, we have already got this data, top 10 data. And if you remember, I told you earlier that this is going to be the syntax for our GGPlot2. There first we will pass the data set and aesthetic for any plot. In the aesthetic, we will pass here the axis information like x-axis, y-axis, and the color, and if you want to pass any other information. Then there will be also, we will be passing here a geom point. So the geom point is like, let's say, if you want to plot here a line plot or bar plot, there you can use this geom point there. All right, just go ahead and run it. So as soon as you run it, you will notice that there is a bar plot. How this bar plot is coming there, if you notice that I told you that earlier, this color, this color is actually dark. This color is dark orange, and thereafter you have here this GGPlot, and the data, and there is the aesthetic. So there you have this one, and then we are just adding here this geom point. In the geom point, we are adding here this column. So it is going to create here a bar plot by summing all the values available in a particular column. And the color, we are just going here orange. So this orange color is actually the outline color. All right. So these outline color, their fill color is actually this color. If you want to know what is the shade of this color, just search it. As soon as you search it, you will get the shade of this color is like this, which is this color. All right, this bar color. Thereafter, we are just going to add here. If you notice one more thing, this plot is actually not ordered in descending order as it was available in top 10 data frame there. So for that, we are doing here aesthetic x equal to reorder country and minus confirmed. So it's going to create here a factor, or you can say it is going to refactor, and then it will put it into a descending order. Just run it. There you will notice now you are getting a proper bar plot. There you have most number of cases at the US, which is actually almost you can say it's almost 20 million cases, and 10 million cases is in India. All right, perfect. Let's go ahead and see here. We have a GGPlot title and subtitle and the caption. So now we are going to discuss here how you can change the title, subtitle, and the caption. Earlier I had shown you that how you can plot this bar plot. Now the time to see how you can add the title, subtitle, and the caption. So to add this title, subtitle, and the caption in your plot, you need to just get your plot. So this one is a previous line of the code which we had already used there. All right, GGPlot top 10 axis there, x equal to the reorder country minus confirmed, y confirmed. There, if you notice, these things are new. We had not discussed these things earlier. If you notice there, you have a geom point. The geom point, the type of this geom point, we have here a color. The color equal to the orange fill color. So this one is going to create a particular bar plot which we had earlier. These lines are here actually new. So there you have the title is equal to the top 10 worst hit countries by COVID-19, and it was for year 2020. Thereafter you have a subtitle. In the subtitle you have COVID-19 dataset worldwide and caption there. All right, if you run it there, so what's happening there, this labs is a function, and then it takes these parameter, and in these parameter, this one is a title. There you have a subtitle, and then you have here a caption. All right. So there in the title, you have this one title, top 10 worst hit countries. So there's title, subtitle, and there you have a caption. So this caption says that the data source is Johns Hopkins University. All right. Let's go ahead and run it. Thereafter, I'm just going to make here a little difference. The difference is that earlier I used here this labs function to put my title, subtitle, and the caption. But here I'm using a GGTitle function. With the help of GGTitle function, I can just put here label and subtitle. So this label is actually the title and the subtitle is the subtitle. We won't have any option to add here the caption. So earlier we used caption to give a credit for a data source, But if you use here a GG title, in the GG title, this caption is not available. All right, let's go ahead and see how you can change the title, the style of this title and the caption. So style of the title and the caption you can change by utilizing a theme function here. If you use here a theme function, and there you have a plot.title. So plot.title equal to the element underscore text. So this one is doing, actually we want to modify the text element in a title function. Then in the subtitle and the caption function, we also want to here modify text element. Then you have here a color. So this color is quite of you can say regular gray, and these colors are light gray. The size of title here is 24. Face is bold. That's mean the title is going to be in a bold. Just run it, then you will understand. So there you will notice the size of this is actually 24. The face is bold, and there this one is kind of a dark gray color, and thereafter you have here COVID-19 dataset worldwide, which is a subtitle. This one is light gray. Thereafter you also have a light gray color for a caption as well. And then we have also used here italic face for subtitle and these data source, that's the caption. Let's go ahead and try to change this text position and these figure size. So the text position, we want to put this text in the middle of this figure. That you can simply do if you put here, just let me see. Yeah, so you need to actually update here this theme update. So what's the difference there if you notice? So this was pretty much simple. We had already discussed this part when we were discussing how to add the title, subtitle, and this part we just added in this section there to modify the modify the color and size of title, subtitle, and the caption. If you want to change the position and increase the figure size, so this line, the first line, is actually being used to change the figure size. So there the figure size is going to be the 14x8, and thereafter I say here the theme gray, the base size is 20. That's when it's going to update the overall text size to the 20. Thereafter this theme update says that this one is same what we had seen earlier. If you notice in the theme we had whatever we had previously, it's the same. There is just this extra term there, adjust. So it's like you are doing here horizontal adjustment. That's mean we are just trying to do horizontal adjustment for the title, subtitle, and the caption. Just run it. So as soon as you run it, you will notice now the figure size has just increased. Thereafter you will notice the title and the subtitle is in the middle of this figure size. Thereafter you have this caption, so we don't want to change this caption. Alright, so that's how you can change the text position and other things. So this could be a problem for us because we don't want to change it every time. So what we can do, we can set that as a, we can set these as a default setting. So we have also applied here a default setting for this theme. So now in the next section, we don't need to update all those things again. So these things are set automatically. Now these things are default for this notebook. So if you run it, there you will notice we did not apply any of these settings, but still we have here a large figure size and here a better title, subtitle, and caption here. All right, perfect. Let's go ahead and see how we can plot a scatter plot for a COVID-19 data. Scatter plot is plotted between two variables x and the y. The scatter plot can be plotted between the continuous variable and continuous to continuous variable, continuous variable to discontinuous variable. That's mean you can also use it for a categorical variable, and a categorical variable to categorical variable can be also used to plot it there together. Thereafter, if you notice here, we are just going to run it here. We are using a US data. In a US data, There we just pass here aesthetic. In the aesthetic, we have x is equal to the date, y equal to the confirmed. So x-axis we are using as a date, y-axis as a confirmed cases. So this one is the total confirmed cases. As of now, we have total more than 20 million cases in US. Thereafter, we are adding here a geom point. In the geom point, we have a size equal to 2. That's mean we are actually plotting here a point plot. So the point plot is actually kind of a scatter plot. If you don't put any the kind of a plot, it actually plot a scatter plot by default. And if you notice, there is a point. So these points are actually a scatter plot. Thereafter, subtitle, title, and the caption, which we had used previously, and the color, the alignment, everything else is already set, which we have already used there, a default setting earlier. Thereafter, we are going to use here a line plot for COVID-19 data. In the line plot, if you notice, a GGPlot is taking here a data and the aesthetic. In the data, we are passing here US data. In the aesthetic, we are passing x-axis as a date and then y-axis as a confirmed cases. Thereafter, you have here a geom line, then size, color, everything else is same without any issue. We are just trying to do here a line plot. All right. If you notice, earlier we used here this geom point. Now we are using here this geom line. So in the geom line, those points are now converted as a line plot here. All right. So the same data we have, just the type of plot here is different what we had earlier. Now we have here a head US. If you check the head of the US, so these are the data. We have the data available from the 21st of January 2020. Let's go ahead and try to plot this data with a different, try to plot here the data with the confirmed cases and the recovered cases together. All right, so we are using here confirmed cases and recovered cases together. Just run it. So what I did here, first we had as usual geom line. One more thing, if you notice here, the data US GGPlot, if you notice there, earlier we were passing these data and aesthetic in the GGPlot, but now we are not passing that. We are putting GGPlot separately, then we are passing the data in geom line. So in the geom line, we are passing the data US and the aesthetic is confirmed cases for one geom line, and for another geom line, we are passing recovered cases and the rest of other things are same. So there you will notice you are getting here confirmed cases and recovered cases. And suddenly you will notice on the day of 13th of December 2020, 13th December 2020, United States of America suddenly stopped reporting the cases. So there are many countries which have suddenly stopped reporting the cases, corona cases. So you need to also pay attention there. If you get a wrong data, that means the data is not being provided by the country correctly. I have also updated that in my data here in repository. I have also updated here few of article which says that why corona cases are not always accurate, because countries are not reporting accurate cases, and recently US after 13th of December stopped reporting the recovered cases. So you won't get the correct recovery after the 13th of December 2020. All right. You may also not get a correct corona cases, especially the recovered cases and active cases for a particular countries. Thereafter, we are just going to here plot this one. Then you will notice recovered cases and recovered cases in US for year 2020. But do you see here any changes and differences? All right. So what we are doing here, we were just trying to put here the different color and other things. You can just change it here. Let's say if you want to put this color to something else here, you will notice here there. So there you have got this color. All right. So this color is different here. All right. Perfect. Let's go ahead and run this one. So there we are getting here death cases. So in the death cases, if you notice, this death cases is increasing continuously. And the moreover, the most of the time, the death cases and confirmed cases are correctly reported by the countries, but the recovered cases and active cases are not being reported correctly. So you need to also pay attention on those cases. All right, let's go ahead and see how you can load, how you can do the analysis and the plotting of the Boston dataset. So there you have the Boston dataset. In the Boston dataset, you can load it from mass package. In the mass package, you will get, these are the actually column of Boston dataset. So there are total 14 column in Boston dataset. There are 13 input variables and one target variable, which is median average, the median value of a house there. So you need to first install here a mass package, install it. Thereafter, I'm just gonna comment this one so that I don't run it 2 times. Thereafter, you need to include this mass package in your notebook. Then we are just going to load this Boston in a Boston variable. Then here head Boston there. All right, so this one is the head of the Boston data, and there is the tail, and there is the summary. So moreover, my main part and my main aim here, my aim is to plot a scatter plot for Boston housing dataset. So the column name here, you have a Boston. So if you put the column name, you will get the name of all the column available in a particular data frame. So there we get all these column is available here. Thereafter, if you run it here, color, so there you get it, there you get it. So there you have got this scatter plot. This scatter plot is a beautiful plot plotted between 2 continuous variable, L stat and the median value. So median value is a house price, L stat is lower status of the population. So that's mean this one you can say the status of poor people living around a particular house. Let's go ahead and see how we can plot a pair plot. So the pair plot is, you can use here GG pairs to plot a pair plot. If you remember previously, I told you that you can use here GGalley. Let me show you here. We used GGalley. So this GGalley is actually used to plot a pair plot. All right. So just come here. Then you will notice a pair plot is plotted here. So the pair plot will be plotted for each combination, for every combination of the data. So because this pair plot is plotted for every combination of the data, and there are a 14 column, so it's going to plot a 14 cross 14 number of 14 cross 14 number of plots here. All right, let's go ahead and try to plot it for lower number of columns. So these are just for a few number of columns. That's mean this is only for 5 number of columns. So this one seems pretty much good looking than what we had earlier. Thereafter, let's go ahead and plot here another package. This package we are actually going to, this package is also used to plot the pair plot. This one will actually plot here a colored pair plot. So this plot says that what is the distribution of a particular variable, and there is ellipse. So this ellipse says that what is going to be the correlation value. If there is a positive angle, that's mean the correlation is a positive. If there is negative angle, that's mean the correlation is actually negative. Let's go ahead and try to see how you can also plot a Titanic dataset. The Titanic dataset is created from the Titanic crash. The crash happened in the 20th century of the Titanic data. Of the Titanic ship. So there it had records of the passenger who had survived that crash and the passenger who could not survive that crash. All right, just run it, the summary. So this says that how many number of columns are present in that particular data set. All right, just go ahead and run it. There you have the data cleaning and the bar plot. So in the bar plot, I'm just going to run it and show you how you can plot a bar plot. So the bar plot I'm plotting here. So in this bar plot, it says that how many people has survived that crash. So it's pretty much simple. GGPlot Titanic aesthetic x is equal to the survive, fill equal to the survive, GGP equal to the geom bar. So it's actually plotting here a bar plot there. All right. Similarly, you can also use here to plot a scatter plot. Column name is there a Titanic. There, if you plot it, there you will notice a scatter plot between age and survive. Since survive is a categorical variable, so we are not getting here pretty much distributed, we are not getting a distributed scatter plot. So it's pretty much a concentrated plot only on survived and could not survive. Let's go ahead and try to plot here this age and fair. So this age and the fair says that what is going to be the age and the fair. So you will notice the age is actually we have almost the people who are the who had age of almost 80. There were a few people who had really paid high amount. There could be possibility that they might have taken the ticket as an immediate ticket. So that could be the possibility that the cost of the ticket is pretty much high. If you plot here a histogram, you can use here a geom histogram. So with the help of this geom histogram, you can plot the histogram for age variable. There it says that there are many passengers who were actually children, all right, and then the most of the people were aged in between 18 years to 35 years. And let's go ahead and just plot it. Thereafter, you have here a fair distribution. So there are many people who had really paid high amount. Otherwise, the most of the people were actually at the downside of the payment. Let's go ahead and see how you can plot this stack plot. So this stack plot says that I mean to say that this stack plot, you have multiple plots plot together. To get this stack plot together, you need to just put here a fill. So this plot is being filled by a particular variable, a variable which is a 6 variable is having two categorical unique values, which is male and the female. So this bar is divided into two categorical values, male and the female. So this says that the number of people, the male, so the frequency of male were high than the female. That's when the total number of male passenger were the larger than the total number of female passenger. All right, so this one is the fair distribution with the 6 male and the female. You will notice there a female, so the female had really quite paid a lot as comparison to the male candidates there. I mean the male passengers there. Let's go ahead and here see age distribution with the passenger class. So age distribution with the passenger class says that the third class passenger, so many people were traveling in the third class. Only the few people, you can say only few people, are a small percentage of people were traveling in a first class. Otherwise, the most of the people were traveling in the third class. Let's go ahead and try to see here. There I have here age distribution. Here in the age distribution, we have survived equal to the 0 and the 1. Thereafter, you have here age. So this age says that this one is age, and then you have here frequency. All right. So age, one thing you notice, mostly the age is concentrated at this place. And this color says that these people and these people. So the most of the people could not survive who were in aged between 20 and 40. This could be a logical reasoning because younger people were not traveling in higher class. There were possibility that the people who were traveling in the first class, they survived mostly. Otherwise, the people who were traveling in the third class, mostly they could not survive. Let's go ahead and see how you can plot the density plot. This density plot says that the distribution of the age there. So you have here a geom density. All right. So you can use here geom density, and the rest of other things are same what we have been using. All right. Let's go ahead and run it. There we are going to use here a fill equal to 6. That's when this distribution plot will be divided with the age. So there you have 6 equal to the male and the female. There you will notice there is a passenger who had less age. All right, I mean younger. So the most of the time you will notice the female passenger were younger than the counterpart male passenger. All right, just run it, another one. So there you will get the survived and could not survive. In this range, you will notice the people who were in age between 20, those could not survive, but the people who were in age between 45, they survived more than those people who could not survive. And you will also notice here, those people, the children survived mostly. So the mostly children survived. And if you notice here, those people who were senior citizen or the age were 70 and the 80 year, those people also survived there. All right, so this one says that the passenger class and age distribution. Now you will notice the people with the higher age were traveling in higher passenger class. That's mean the first class passenger. Those people who, this is also logical. Let's say if my age is 50 year, definitely I would be able to save more than what currently I have. If my age is just 20 year, then I might not have much money to get the higher class ticket. So I might prefer to travel in the third class. But if I have earned a lot and if I have saved a lot of the money, then I might want to travel in the first class when I'm 50 and the 60-year-old. All right, let's go ahead and see how you can use a box plot. If you notice here one thing, there is just a change of this box. There is just a change of only one geom point. Otherwise, rest of things are same. So you don't need to worry about that. Rest of things are same. You just continue with the lecture. There, you just need to put their geom box plot, geom line plot, point plot, call plot, or hist plot, whatever you want to use there. Just run it. There, this box plot says that the average age of female passenger were less than the average age of male passenger. Thereafter, let's go ahead and see here, age survived, all right, the column. So this age survived column says that there you have the people could not survive who were in this. The most of the people actually could not survive. We don't get much of the clear data by this plot. Let's go ahead and try to see if we get any clear understanding for, so there I get a clear understanding. So this says that the male passenger could not survive. So the frequency of male passenger who could not survive were high here, but the frequency of those passenger who had survived, that was the female passenger. So the mostly you can say that in the Titanic crash, the most of the female passenger as comparison to the male passenger survived that crash, but the male passenger and who were traveling in the third class could not survive. So the probability of the survival was really very low for those people. If you are traveling in the first class and if you are male, if you are a female and first class, otherwise if you are traveling in the first class and you are a children, then the probability of survival was quite high. Let's go ahead and see how to plot this violin plot. All right, this says that sex-wise distribution. So there you will notice the female passenger survived. So the most of the female passengers survived. Only few female passengers died. And here only few male passengers survived. Otherwise, most of the male passengers died in that Titanic crash. Let's go ahead and finally see how we can plot violin plot. So there we have a GGPlot. If you notice, just we need to change here one thing, geom violin, and rest of things are same here. So this violin plot there, and it says that age wise. So age wise we don't get here much data, but one thing we get here as a clear point that there is a fatty area here. This fatty area says that those people who were aged in between 0 to 5 year and 10 year, the survival probability was quite high. And those people who were aged between 70 to 80 year, the survival probability was also quite high for those people as well. Let's go ahead and see this violin plot there. So there you have sex-wise and male and the female. There one more thing, if you notice there, the male passenger, the most of the infants are younger people were traveling there male. So there the survival probability was also quite high there. Let's go ahead and try to see this one, a passenger class wise. So in a passenger class wise, if you notice, these are the first class passenger. So the most of the people in the first class passenger from this from the infant to pretty much elder people, all those people mostly survived. But in the second class, but in the second class, mostly people died, and the third class also, mostly people died. Only the few people could survive. If you see, the fatty area is pretty much high here and here in this case, but in the first class here, this one is higher than in the survival. So what you get by this plot is that if passenger is a female, and if passenger is traveling in a first class, and if passenger is actually younger or elder, then pretty much high possibility or high probability that that person is going to survive that Titanic crash. Alright, so this is all about in this lesson. Thanks a lot for watching it. I would like to also request you, please do like this video, and if you have any doubt, comment below, and you can subscribe this channel so that whenever I start making new videos, you will get a notification in your email that I have started my live channel video. Alright, thanks a lot for watching. Bye bye, take care. A notification in your email that I have started my live channel video. Alright, thanks a lot for watching. Bye bye, take care.